All right, welcome everybody. Hey, guess what, guys? You made it to the end of Unit 1. Give yourself a big hand. You guys have worked real hard on this unit. Been a lot of information, so let's kind of get to this real quick. Let's get this study guide done. This is the same one we did in class today, but I do want you to have this one to look at tonight, as if you need a little refresher of what we did. Okay. All right. So the first part, man, we talked about. We looked at these at the upper part. I told you what we're going to go over these. You can read for yourself. What's the difference between similar, congruent? Which ones are rigid? Which one are non-rigid? Remember enlargements and reductions on your scale factors. Okay. So let's look at the first problem. We're going to determine the sequence of transformation. Remember sequence. Okay. Remember a sequence is two or more transformations done to an object to give you a new object. Well, here we have triangle ABC and triangle GHJ. Okay. So if you look at this, we can look and see how did I get ABC to become GHJ. Well, the first thing I notice is it got bigger. Okay, two things I do notice: it changed direction and it got bigger. Okay, so we know somewhere in there it's got to be some kind of dilation. Okay, so we'll talk about what we know first. Well, we know it also changed direction. Okay, remember, notice if it did change direction, but it did not turn, so the only one that changes direction without turning is a reflection. All right, so we know somewhere in here we did a reflection and we did a dilation. Well, what kind of reflection did I do? Well, if you look, this translation, this one moved from here to here. So basically what you actually did was you did a reflection. 1, 2, 3, 4, 1, 2, 3, 4. And then 1, 2, 1, 2. Excuse me, that's going to be a 2 up here, will, isn't it? Excuse me. All right, so 1, 2, 1, 2. So here is B prime, I'm sorry, and this is C prime. So if you look, we changed direction here, and then we got bigger. So we know we did a reflection across the y-axis. All right, now we got to make it bigger. So remember, we're looking at with dilation. Remember, one thing you tell me with dilation, you have got to tell me that scale factor. What did I multiply it by to get it be bigger? Remember, scale factor is that lowercase k. Well, remember, if we're doing scale factor is the new shape over the old shape. Well, this is my new. Here is my old. Okay, I'm going to pick a point. It doesn't matter which point I pick. I'm going to pick that point, and then the prime part of that, the next one. So if I look, here's A and G are the same point in this triangle, but if I look up here, A goes with G, so I can use A and G, and I like using A and G because it has a 0 in it. So point A is at 4, 0, sorry, A prime, and G, excuse me, is at point 10, 0. Well, remember, if I want to do new over old, well, I can't use the zeros, so I'm going to be real easy. I'm just going to use this 10. 10 over 4 is my x coordinate, and if I put that in my calculator, I should get 2.5. So the sequence here was a dilation over the y-axis, dilated by a scale factor of 2.5. Okay, changed direction and got bigger. Okay, I'll just go to the next one. Which one of these is rotated about the origin? Okay, so I want to know which angles match up. Well, to start with, it's a lot easier if you can't visualize this thing turning here. We're going to talk about what we talked about earlier in the year. Let's talk about our signs. Quadrant 1 is positive, positive. Quadrant 2 is negative x, positive y. Quadrant 3 is negative x, negative y. And quadrant 4 is a positive x, negative y. Well, to figure this out real quick, we're just going to go ahead real quick and we do a 90-degree clockwise, which means it's going to go from here to here. All right, figure 1 to figure 2. But I need to figure out which one is which. So the easy way to do that, if you can't visualize this, just start writing down your coordinates. Well, here is M, here's N and O and P, right? M is at 1, negative 5. N is at 1, negative 3. O is at 3, negative 2, and P is at 5, negative 4, right? All right, so remember, if we're doing a rotation, 90-degree anything, the word that should jump into your mind is switch the order of the pairs and then fix according to the quadrants, right? So if I switch and I fix, well, if I switch, 1, 5 becomes 5, 1. And if I go into quadrant 3, I know both of those are negative. So what coordinate is at negative 5, 1? There's C. So C is there. So M is congruent to angle C, or vertice C. All right, here's N. So if I do N from 1, 3 becomes 3, 1. Both of those are now negative because we're in quadrant 3. Well, at negative 3, negative 1 is D. So that would be angle D is congruent to angle N. O, you have 3, 2 becomes 2, 3. All right, since both of them are negative, that's at negative 2, negative 3, which gives me coordinate A. So that's O is angle A. And P, 5, 4 becomes 4, 5. Both of them are negative. So at 4, negative 5, you have point B. Okay, so angle B. All right, remember when you test tomorrow, it may not be that hard. It may not be that difficult. You may have to do just one coordinate. But if you can't visualize that rotation, write down your regular pairs and then turn right around and switch them and fix them. Okay. All right. Number 3. What happened to go from, how do I get, in this triangle LMN is congruent to triangle XYZ. What I want to know is which sequence, so here we go again, more than one, transform triangle LNM will result in triangle XYZ. So we're going from here, here's my old, to my new. All right. So let's talk about what we got. So 180 rotation. Let's talk our way through this. 180 rotation about the origin followed by reflection across the y-axis. Well, 180, that is 2 quadrants, right? Well, if I go 2 rotations, 1, 2, either way, that puts me here. And then if I reflect across the y-axis, that would put me here. That's not where my shape is, so we know it can't be that one. All right. Let's go with the next one. Triangle at 5 units up followed by a 180 rotation. All right, so if I go up 5, 1, 2, 3, 4, 5, well, my point is at 0, negative 1, but remember with a 180, we're going to change the sign, so that would put it there. All right, let's try M. So that one checks. 1, 2, 3, 4, 5. That's 1, 2. Well, if I change the signs, it becomes negative 1, negative 2. There's Y. What about L? 1, 2, 3, 4, 5. That's 3, 1. Well, if I change both signs, or multiply by negative 1. I know some of you are already hollering at me about that. If I change both signs, negative 3, negative 1, there's X. That checks. There's my answer. Okay, but let's keep going just to make sure we can understand there's not more than one. All right, 90-degree counterclockwise rotation would take it from 3 or 4 into 1, and if I reflected it back across the x-axis, it puts it right back into the same quadrant, so it can't be that one. Okay, reflect across the y-axis followed by a scale factor of 1.5. Well, I can do this right now without even looking, because that means it would get bigger, and if you look, these two are the same size, so it can't be D. All right, so how it works? Good. All right, what about this one? Quadrilateral WBGD is reflected over the y-axis and then translated 6 units down. Okay, so I'm going to do this in one step. Okay, so I'm going to reflect first, then I'm going to count down. It's going to say what are the new coordinates. So what I'm looking for are W prime, G prime, B prime, and D prime. All right, so if I do W first, if I reflect, remember it's just counting. 1, 2, 1, 2. And then we're going to translate 6 units down. 1, 2, 3, 4, 5, 6. Well, there is W prime, and that coordinate is negative 2, negative 2. Here's G, 1 to the line of reflection, 1 over here, and then count 1, 2, 3, 4, 5, 6 down. There is G prime, and that's at negative 1, negative 3. Here's B, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. There is B prime, and that's 1, 2, 3, negative 3, negative 2. And then finally, let's do D, 1, 2. Two points away from the line of reflection. So I go over 2 and down 6. 1, 2, 3, 4, 5, 6. All right, there is D prime, and that coordinate is negative 2, negative 5. All right, and if I connect my shape, there's the shape after it has been reflected this way and then translated that way. Okay, so we change directions and then we just slid it down. Okay, good job. All right, here we go. Describe the transformation before or after. So here's my before image. This is what happened before. This is the after image. Well, if you look, Here, all I did was change the directions. This is a reflection across or over, however you want to say it, the y-axis. Okay, it changed directions. Look how it did. If you look, 1, 2, 3, 1, 2, 3, it should be at -3, +2. There it is right there. There's the M. Okay, so look how it works. All right. What happened here? The transformation resulted in dLW becoming d prime L prime W prime. So here it went from here. So we know I only went one quadrant. So that's 90 degrees. All right. And it changed direction. So you know it can't be a translation. So it's got to be a rotation. It can't be a reflection because the images are not in the same distance from the line of reflection. Can't be a dilation, so it didn't get any bigger. So what you have is a 90-degree clockwise rotation. Okay. Remember, we talk about clockwise. Remember, clock is 12, 3, 6, 9. So if you're going in order like the clock, that's a clockwise rotation. It's a rotation to the right. Okay. We rotated to the right one quadrant. All right. What about this next guy? Describe the transformation shown. Well, if you'll look, D, E, F, G, my letters, my vertices are in the same order, so it can't be a rotation or reflection, and it didn't get any bigger, so the only thing it can left be is a translation. Well, how far did it go? Well, let's try D. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Just to be safe. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So with translation, 7 units right and 3 units up. And remember, if I notation with that, right means X, right also means plus, X plus 7, up means Y plus 3. So we have a translation, X plus 7, Y plus 3. All right? All right, here we go. In the image below, QRS has been rotated 270 degrees counterclockwise. Well, we know we like that number, but we also know if it's 270 counter, that's the same as a 90 clock, right? So all we did was here to here. Remember, three quadrants will be 1, 2, 3. So it's the same rotation. If angle R measures 74 degrees, which I know for a fact, you know, y'all do too, that is a obtuse angle. Does measure more, but we just kind of roll with this. Okay, I'm sorry, that's R. Same thing. So this is R. What is R prime? Well, remember, it's 74 degrees because the triangles are what? What's that word? It starts with a C. That means equal measurement, right? Okay. So if they are equal, remember, if they are congruent, that means they're going to have the same angle measurement, same size, same shape, and same side lengths. Okay. So nothing's going to change. So these happen to be, because these are congruent. It would really be the same answer if they were similar. Okay. All right, let's go real quick. Number 9. What happened here? Well, if I look, here's R, and I know, guys, these are supposed to be up here. This is T, and this is T prime. I apologize when I copied it. Okay, here's U, should be right here, U prime and U. So if you look, everything is the equal distance from that line of reflection. Matter of fact, U is still there. So this one is a reflection over or across. Let me back this up. The y-axis. All right, and that's all you're doing is walking yourself through this type and see. Okay, it didn't turn. If it did, that T would have been down here, right? Okay, didn't flip. If it did, it have been down here, and it didn't get any bigger. So all you're left with was a reflection. Okay. All right, here we go. Indirect measurement. I know the height of this wall. I know the shadow it casts. What I don't know is how tall is the tree. Okay, I've given you a hint, and guys, remember, it doesn't matter. I can use height over height. If I do tree over wall, then I've got to do shadow of tree over shadow wall. But I like to keep mine together. Remember, we talked about this. It doesn't really matter as long as you are consistent. I like to do tree on one side, wall on the other, right? So the height of the tree over the shadow of the tree is equal to the height of the wall. Excuse me, I do know that. Height of the wall over the shadow of a wall. Well, if I cross multiply, 6 times x is 6x. 24 times 4 is 96. If I divide by 6, that's going to give me x is equal to 16. This number right here tells me the tree is 16 feet tall. So a tree that is 16 feet tall casts a 24-foot shadow. All right? So just remember, try to keep it consistent. Doesn't matter how you set it up, as long as on the left you set it up on the right, okay? All right, scale factor. What's a scale factor? Remember I gave you a hint. New shape over old shape. Well, in other words, remember we also talked about this. Prime divided by not prime. Right? So here we go. This is the one I want you to watch because remember we talked about this today. I don't know exactly what A prime, J prime, and L prime. I don't know where they are exactly. I do know where A, J, and L are. But over here, I don't know exactly what those numbers are. So I'm going to use P and P prime, or P and P prime, excuse me. So if I say P, that's at point -4, +4. P prime is at -1, +1. Well, if I use my rule up here, new over old, or prime divided by not prime, if I take my X and then I take the Y, I should get the same thing. So I'm going to go P prime over P, right? -1 over -4. Well, 1/4 has been reduced as far as it would go. Negative divided by negative is a positive. And then some of you today got this as well, 0.25. That's fine. So there's my X coordinate. Let's check the Y coordinate just to be safe because remember my scale factor has to be the same. Well, that's as far as it'll go, 0.25. So you'll see either one of those on as your answer choices. Usually it'll be a fraction still. Okay, sometimes it'll be that decimal. And since we talked about this before we get any further, this was, what was that word? Good, you guys remember the word reduction. Okay, it got smaller. All right, oh my goodness, here we go. Fill in the angle measurements. All right, real quick. There's a couple up here I can find right off the bat. I can find B, I can find A, and I can find E. So it's like a puzzle, right? So if I look right here, A and 70 are vertical angles, right? Those are vertical angles. And vertical angles are congruent, so if that's 70, that's 70. Now I can do a couple other things. Here, if you look right here, these two are alternate interior angles, or these two are corresponding angles, which means that both of them, either way you want to do it, they're still 70 degrees, right? Okay, good. So now I can find B, because if I know these two over here, one is obtuse, one is acute, then I know these two are supplementary, right? These angles are supplementary, which means they have to equal 180 degrees, right? Well, I know 135. How do I find B? We just subtract. Okay, so that should be 45. So B is 45. Well, I can go one step now. If I know this is 45, I know these two are alternate interior angles, so those two are 45. Now, I can find this triangle. If you'll remember, we did several of these, and you guys were knocking these out of the park, doing an awesome job, right? Well, remember, triangles have to measure 180 degrees. Well, if I know these two measurements right here, what I can do is 45 plus 70 is 115. And if a triangle has to equal 180, I can just subtract 115 from it and get, what is that, 65? So angle C is 65 degrees, right? Well, remember the other way you can do that was also too, you got three angles here that make a straight line, so you'll get the same measurements. Another way you could also do that is, remember, if you have 180, subtract 45, subtract 70, because you have your calculators to do it for you, will give you 65. Either way you want to, remember there's 2 or 3 ways to do it, okay? All right, be careful here. Remember we talked about this today. This looks vertical, right? But if you look, this is an obtuse angle. I'm sorry, acute angle. That's obtuse. They can't be vertical, right? But look right here, same thing here. This is obtuse and acute. Same thing here. So I can get this one based off of that one, correct? So supplementary angles, obtuse and acute. So 180 minus 70 gives me 110. So the measurement of F is 110 degrees. Okay? So just walk yourself through these, right? Remember we talked about it. If you can tell me what it's not, then you can tell me what it is. All right, real quick. Angle 1, 129. Okay, 2 parallel lines cut by 1 transversal creates these 8 angles, right? Well, if I look up here, angle 1 is an obtuse angle, right? That means every obtuse in this one is also going to be 129 degrees. Vertical, alternate interior, vertical. Remember zigzag? Okay? All right. Then I can go back and find the other ones. Well, because 1 and 2 are supplementary, 180 minus 129 gives me 51. So angle 2 is 51, and it is an acute angle, so all of these acute angles are 51 degrees. Okay, remember, it doesn't work every time for a lot of stuff, but for this stuff it works every time. When you find one obtuse, all the obtuses are the same. Okay, same thing for the acute. All right, remember we talked about this one in class today. If you guys can't picture this, turn your paper 90 degrees clockwise, and what you actually have is something that looks like that. Okay, because this line is this line, this one is this one. Okay, so that's what this is kind of the vision you had in class. So make it look kind of like that. Okay, all right, so let me back that out. So now we can figure our angle measure. So real quick, and remember the triangle's up top. I see a triangle, so I like to remember, as soon as I see that triangle, I like to shade it, right? Because I do remember that triangles have to equal 180 degrees, right? All right, so real quick, if I go through here starting at the bottom, these two are vertical angles, congruent. These two are alternate interior angles, which means they are congruent. These two are vertical angles, which means they are congruent. Then I can find here 16 and 65 are supplementary. So 180 minus 65 is 115. So angle 16 is 115. 16 and 19 are vertical, which means they are congruent. 19 and 14 are alternate interior, which means they are congruent, or they are corresponding, right? Okay, and then if I can get right here, these are vertical angles, 14 and 17, so they're 115. Or you could say they're corresponding here, or alternate exterior here, or supplementary here. So there's a bunch of ways to do that, okay? All right, let's go do the other side. If that's 45, 6 is 45 because they are vertical. That means this is 45 because they are alternate interior angles. 9 is 45 because they are vertical. And then now all I have left are my obtuse angles. Well, if I know that's 145, 6 and 12 are supplementary angles, right? That's 135 degrees. And now every one of these obtuse angles up through here, because that's vertical, 5 and 12 are vertical, 10 and 5 are alternate interior, or they're corresponding here. So they are congruent, which means they measure the same. And then finally, angle 3 is 135, right? Okay, so then we have our triangle again, just like we just got through doing. Well, either way you want to do it, you can subtract 65 and subtract 45. Okay, so if I take my calculator and I do 180 minus 65 minus 45, should give me 70 degrees, right? Or we can say 65 plus 45 is 110, and then 180 minus 110 is 70. So there's two ways to do that. Either way, you're going to get the same answer, okay? And then you have vertical angles here. 1 and 8 are vertical, so that means they are congruent. And then 1 and 2 are supplementary, so 180 minus 70 is 110. And then these are vertical, so that's 110. Okay, so see how it works? Once you learn that one side, the other side will falls right in with it. Okay, all right. Whew, real quick, alternate interior angles. Remember what we're looking for here. These are inside matches. You're looking for angles that are the inside that match. Okay, so if I look inside, the only 4 angles inside are 3, 4, 5, and 6. Well, 4 is an acute angle. The only other acute one inside is 6. And then so you have 3 and 5. Now, are they congruent? Yes, sir, they are congruent. Yes, they are congruent because when they have the same measurement, number one, because they're the same types of angles, but by the rule of alternate interior angles, when 2 parallel lines are cut by a transversal, alternate interior angles are congruent. Okay, I didn't write all that out, and I hope you can remember that. But remember, line M and N are parallel. They're cut by transversal P. So that creates these angles, and alternate interior angles are congruent, right? All right, so angle 16. So what we're looking for, alternate exterior. So here you're looking for outside matches. All right, so what's on the outside in matches? Well, on the outside you have 1, 2, 7, and 8, or 1, 2, 8, and 7, excuse me. So what matches? Well, 1 is obtuse. The other obtuse outside is 7. So 1 and 7 and 2 and 8. And by the same rule, yes, they are congruent, and the reason being is because parallel lines cut by a transversal produces alternate exterior angles that are congruent. That's just the theorem of alternate exterior angles. Okay, supplementary match to angle 1. Remember, supplementaries have to equal 180 degrees. But also remember, supplementary for this part, we're talking about 1 obtuse plus 1 acute, right? All right, so real quick, if I look up here, angle 1 is an obtuse angle. To find anything that is supplementary to it, just find an acute. Well, here's 2, 4, 6, and 8. All of those are the acute angles. Okay, so the same thing here. Now, for supplementary to angle 1, same thing, 180. So angle 2, excuse me, angle 2 is an acute angle, right? So the supplementary to it will be anything that is obtuse. Well, in this case, you have 1, 3, 5, and 7. All right. All right. Vertical angles. What are vertical angles? Remember, we talked about vertical angles being anything that's at the diagonal matches at the same intersection, right? All right. So if I cross here and I cross here, right? Diagonal matches at the same. Excuse me for a second. Okay, so we're looking at diagonal matches at the same intersection. So here, 4 sets, 1 and 3 at the upper intersection, and 2 and 4. So we have 2 at the upper intersection, and 2 at the lower intersection. So 5 and 7, and 6 and 8. 5 and 7, and 6 and 8. And yes, they are congruent as well. By the same definition, the theorem of vertical angles are when two parallel lines are intersected by this transversal, vertical angles are congruent to each other. Okay, fill in the blank. Angle 1 corresponds. Okay, remember corresponding. If I'm looking for corresponding angles, I'm looking for the same angle at a different intersection. Well, angle 1 is above the parallel line to the left of the transversal. Well, at this other intersection, there's only 2 angles above the parallel line, which is 5 and 6. Well, to be to the left of it, to be corresponding, it has to be to the left. So there's your angle, angle 5. Okay, so angle 5. All right, so what about my angles that are corresponding? So what about the rest of them? You have 1 and 5, 2, 6. So 1 and 5, 2 and 6, 3 and 7, and 4 and 8. Okay, same place, different intersections. In other words, remember we talked about this before. If I was to cut this, pick a pair of scissors and move this intersection down, which one would be on top of the other one? Okay. All right. See how that works? Good. All right. We're almost there. Bear with me, guys. Okay. Whew. Take a deep breath. You guys have earned it today. Okay. All right. Take a deep breath. Take a break and come back and see me. All right. Welcome back. All right. So what we're going to do is we're going to finish this out this last little bit. Which vocabulary word describes this equation? Well, if I look right here before I do anything, when I see that number, I automatically know we're talking about supplementary angles. We're talking about supplementary angles because they equal 2 or more angles added together to equal 180 degrees. Plus, if you look right here, you have an obtuse angle and you have an acute angle. All right. Well, let's solve it and let's find the angles. Ready? I'm going to be real lazy. I'm not going to write this out again. But I'm going to draw my river to separate the equation. And I'm going to come in here with my boxes and my circles. Box, circle. Don't forget that plus sign. Remember, boxes, variables get boxes, circles get numbers. Circles get numbers get circles, right? All right. Don't forget the negative sign here. Okay. So one thing I want to caution you against too, please, right here. These two are on the same side. So all we're going to do is pretend like we're dumping all these into one big box. If I have 2 x's and I add 2 x's to it, I have a total of 4 x's. Okay. Now this says plus 43 minus 3 is 40. So that's saying 43 minus 3 equals 180. All right. So then I have a box, which is around my variable, circle, circle, right? Well, now my variables are all on the left side. So I want to move my numbers to the right. So let's get rid of this guy by subtracting. We want to add the opposite. We want that to be 0, right? All right, so we have 4x is equal to 140, right? All right, next step, divide by 4. X should give me 35. Let's make sure, just to be safe, 140 divided by 4 gives me 35. Good. Okay, so now that is the value of X. That still doesn't give me my angle measurement, so we're going to go right back over here. We're going to take this number, we're going to plug it in here, then we're going to take this number and plug it in here. Alright, so let's see what we got. 2 times 35 plus 43. So let's see what we got there. So we have 2 times 35 plus 43 should give me 113, right? Equals 113. Then I have 2 times 35 minus 3. Well, this is a number I can do. 2 times 35 is 70, minus 3 is 67. So this angle right here is 113. This angle is 67. If I am correct, they should equal up to 180 degrees, which they do. Okay? All right, so that we know that's correct. Let me move this out of the way because we're going to have to use this real quick. So 113 plus 67 is 180, right? Okay. So now we're down to just a couple more left, guys. I know you're doing an awesome job. I know you're getting tired, so let's work a little bit harder. All right, so here we go. What vocabulary word describes these two? Well, they are both obtuse angles, so we know it can't be supplementary. And plus, if you look right here, the equal sign is between these two. So this is telling me that these are congruent angles. So it can only be AIA, which is alternate exterior, alternate interior, corresponding, or vertical. Well, they're not on the same side of the intersection, so they can't be corresponding. They're at two different intersections. They cannot be vertical. So that means AIA, which is alternate interior or alternate exterior. Well, they're both on the outside of the parallel lines, opposite sides of the transversal. So these angles are alternate exterior angles, AEA. Okay? All right, so let's solve it real quick. So 3y plus 53 equals 7y minus 55. All right? So I'm going to draw my river, separate my equation, and I'm going to come back really quick before I do anything. Box my variables, circle my numbers. Okay? Now, this is where some of you were getting kind of lost today in the last couple of days. Remember, if this is on one side of the river equation, this is on the other side of the equation, I can't combine these. This is not 10y. So what we're trying to do, remember, we're trying to get boxes on one side or variables on one side, numbers on the other. So I've got to do a little bit of moving around. And I don't like to deal with negative variables, so I'm always going to try to take my small variable to my big variable. Well, the opposite of 3y is to subtract 3y, right? This gives me 0. Bring down the 53. Now, 7y minus 3y. Now they're on the same side, so now I can combine them. 7 minus 3 is 4. Okay, don't forget your y. Minus 55. All right, well, I still have my circle. Now I have my box and I have my circle. Well, now all of my boxes are on the right, so let's move this over here. The opposite of minus 55 is plus 55. That's going to go away, so I have 4y is equal to 108. 108. And then if I divide by 4, I should get y is equal to 27. Okay? All right, let me make sure just to be safe. 108 divided by 4 is 27. Okay, so now if I go back over and plug this in, when I plug it in right here and right here, my numbers should come out the same because we said these were alternate exterior angles, and alternate exterior angles are congruent. So if I go 3 times 27 plus 53, let's see what we got here. Okay, 3 times 27 is that, plus 53 gives me 134 degrees for this angle right here. Now let's see what we have down here. 7 times 27 minus 55. Let's just see what we got. Okay, 7 times 27 is 189 minus 55. Excuse me. 7 times 27 is 189 minus 55. Not 555, I'm sorry. No wonder it messed me up. Minus 55. Hold on. Let's reset this thing. Let's pull up another one. 7 times 27 is 189. And if I subtract 55 from it, I get 134. There's my number I was looking for. And since these two are equal, that means they are congruent to each other, which means that that number right here is correct. Okay? All right. 24. Graph the image on the coordinate plane using the coordinates below. We're going to dilate it first, and then we're going to translate it that. Okay? Well, if I look right here before I do anything, I know this should be a reduction. So my figure is going to get smaller because my scale factor is less than 1, right? All right, so let's graph it real quick. If I was to graph these points, there's S, there's T, there's L, and then there's F, right? So here's my shape. Now we want to dilate it by a scale factor of 1/2. Well, remember, dilate, what you're looking for, that means to multiply, right? So we're going to dilate everything. So that means we're going to multiply this time. Everything's going to be multiplied times 1/2. Okay? Well, 1/2 is pretty easy to fool with. Sometimes you can say, just what is half of a number? Well, 0 times 1/2 is 0, right? So here's S prime. 4 times 1/2 is 2. What's half of 4 is 2, right? Half of -4 is -2. Half of 4 is 2. Half of 0 is 0. Half of 2 is 1. -4. Half of -4 is -2. 1, right? All right, I'm going to do a different color. Even though I did that in blue, I'm still going to do it in red. Okay? So let's graph this. So here we go. Now L and S prime are the same number. T is right here. L is right here. L prime, excuse me. And F prime is right here. All right? So now we're going to move it 5 right, 3 down. So just going to count 5 units to the right, 3 units down. 1, 2, 3, 4, 5. 1, 2, 3. That would be S double prime. So we'll say that is 5, -1. Is that right? Good. All right, let's do T. 1, 2, 3, 4, 5. 1, 2, 3. There is T double prime, and that is 3, -1. Then L, 1, 2, 3, 4, 5. 1, 2, 3. I'm sorry, 5 and 3, right? 1, 2, 3, 4, 5. 1, 2, 3. There is L double prime. That is 5, -3. I'm sorry, 5, -2. And then let's get the last one is F. 1, 2, 3, 4, 5. 1, 2, 3. There is F double prime, and that is 1, 2, 3, -2. Okay, so there's my new coordinates. Okay, it shrank, and then it got slid over and then down. Okay, see how it works? Good. All right, 25. Let's roll through this pretty quick. We're almost done, guys. Hang with me. All right, before we do this, remember we got to do a little work. What we want to do is what kind of angles and what sides. Which angles go together, which sides. So if I start with this triangle, ABC is similar to HGF, right? Before I do anything, I want to know angle H is equal to angle H. Angle B, the second one here, and the second one here. So B is equal to G, and then C, the last one here, the last one here. So C is congruent to angle C is congruent to angle F, right? Which means they have the same measurement. All right, what about side lengths? Okay, so if I take the first two side lengths, AB is similar to HG. Okay, HG is segment. Okay, BC, the second and third, So BC is segment GF, and then finally the first and the third, which is AC, is similar to HF, right? It's congruent to, excuse me, not similar. Okay, so here are my angles. Here are my side lengths. This is what we're going to use to set up our proportions, okay? All right, first of all, what is the scale factor when dilating HGF from ABC? All right, so here's the key right here. We're going from HGF from here. So this is going to be my old. This is going to be my new, right? Remember, scale factor is new over old. Well, the only two numbers I can use are 8 and 48, right? Okay, so here we go. Let's do new over 48. By the way, this should be a what? This should be a reduction, right? So it should get smaller, which we know it did, right? So if I set that up, my scale factor is 1 over 6. So from here to here, my scale factor is 1/6. All right? But then it wants me to change around and go the other way. What is the scale factor when dialing ABC from HGF? Well, if I turn it around, all I'm going to do is turn my fraction around. Okay? Turn my fraction around to 48 over 8, which is 6 over 1, or 6, right? So this should be an enlargement because it got bigger or larger, right? Okay. Now, some of you have figured out how to use this scale factor. It all depends on which way I'm asking you to go. Okay. So, but we're going to go ahead and do the proportions first. Remember, because similar triangles have proportional sides, so we're going to set up our proportion. All right. So let's find the value of x. Okay. So if I set up a ratio of x over 48, because I can't use the y, right? So if I set up a ratio of x over 48, okay, this is where this comes in over here, right? So x is on side AB. Well, what is congruent to AB, or what is similar to AB? Well, HG. What is on HG? There's 12. So my ratio is x over 48, 12 over 8. All right. So if I cross multiply here, I have 8x. If I cross multiply here, 48 times 12, let's see what that is. I think it's 576. 48 times 12, yep, 576, okay, equals 576. And to find the value of x, all I'm going to do is divide both sides by 8. So take that number, divide it by 8, and you get 72. So x is 72, okay? And this is what I was talking about. Some of you have figured this out. If this is 12 times, excuse me, 12 times your scale factor of 6, 12 times 6 is 72. Some of you figured that out, and that's easy. Either way to do it, either way you want to do it, it's fine with me. It doesn't matter. All right, what if I want to find y? Well, let's just stick with that 48 since we know 8 goes with it. Well, y is on side AC, so if we do y over 48, we got AC over BC, right? So AC is HF over GF, right? Which will be 14 over 8, which is 14 over 8, right? Well, if I cross multiply, I have 8y, and then 48 times 14, 48 times 14 is 672. Then we're going to divide by 8. Y is what? 672 divided by 8 should give me 84. And again, those of you that have figured this out, 14 times 6, which is my scale factor, would give me 84. Okay, so there's two ways to do it, whichever one you prefer. Okay, all right, so finally, we're almost there. 3 problems to go. If angle A measures 29 degrees, right? Here's angle A. What does angle H measure? All right, so if this is 29, what does angle H measure? Well, remember, it doesn't matter if it's similar or congruent. They're going to have the same measurement because the triangles, and I'm going to abbreviate or put a symbol, right, are similar. And remember, similar triangles have the same angle measurement, right? All right, same thing goes here. If angle B is 85, what is angle G, right? So B and G, do they go together? Yes, see, here's angle B and angle G. So whatever they are, they have the same measurement for the same reason, because the triangles are similar. Okay? All right, last one. Whew, a lot of work. This is the one that takes a lot of work. All right, so what's right here? What this is telling me is this angle right in here measures 4x minus 8 degrees. This angle measures 5x minus 19. Well, it wants to know what is x and then what is y. Okay? Well, if I'm setting this up, the first thing I notice, and I know it's kind of hard to see, this angle is obtuse, this angle is acute. So right now, I know I can set up this, because these two angles are supplementary angles. Okay? These two right here are supplementary angles, right? And supplementary angles have to equal 180 degrees. Okay? So this is what we've been working on. You guys have been pretty good at this. Some of you still are just a little bit unsure of yourself, and I don't want you to be unsure of yourself, because this is something that you guys can do, and we're going to see a lot of this year. Okay, so if I look right here, I have a box here and I have a box here. They're on the same side of the equation, so let's just combine them. This says 4 plus 5 is 9x. Now this is where you got to be careful right here. Negative 8 minus 19. If you were to put this in your calculator, please put it in like this. Do not put it in like this, because the difference in these two answers is this is going to be 11, because it's going to keep, change, right? Here's just your integer rule. Same signs, add and keep, right? 9x minus 27 equals 180. Let's see what this will do. I want to show you what I'm talking about. If I put this part in my calculator, okay? So if I put in negative 8 minus 19, I get negative 27. You see that? But now if I was to put it in like this, negative 8 minus negative 19, so you have a double negative, a double minus sign right here. It's going to keep this one. It's going to keep this one. It's going to change this one. It's going to change this one, and you're going to get 11. Okay, so be very careful when you put this stuff in your calculator. All right? All right. Guys, we're almost home. Woo, last one. So I box, and I circle, right? Well, all of my variables are on the left, so let's move this number to the right. So the opposite of that is minus 27 is to add 27, right? Goes away. I have 9x is equal to 207. That's all I did was add these two. All right, and let's see, if I divide this by 9, I have 207 divided by 9 gives me 23, right? So the value of x is 23. All right, now I can find this angle, but it really doesn't matter to me right now, because what I need to know is what is this angle. But let's just go real quick. What is 4 times 23 minus 8? Let's find the actual measurement right here. 4 times 23 minus 8. So 4 times 23 is 92 minus 8 is 84, right? So this one is 84 degrees. Well, I can do a cheat because I know these are supplementary. That should be 96, because 180, right? Because you told me we started out with that these were supplementary angles. 180 minus 84 is 96, but we're going to be safe. Just to be safe, let's see. 5 times 23 minus 19. Let's just be safe. 5 times 23 minus 19 is 96, okay, which is exactly what we wanted it to be. So this angle here is 96 degrees. Okay, let me move that out just a little bit where you can see it. Let me move it out just a little bit. Okay, which is 96 degrees, right? Well, I can cheat right here. Look right here. This angle and this angle are alternate interior angles, right? So if that's 84, that's 84. Or it's supplementary here, so 180 minus 96 is 84, right? And then finally, so the value of x was 23, I'm sorry. So now we're inside of another triangle. And remember, again, triangles have to equal 180 degrees, right? So triangles have to equal 180. Well, I know 84, and I know 54. So if I have my calculator, 180 minus 84 minus 54 should give me 42, right? So the measurement of y is 42 degrees. Okay? All right. Whew, that was a good one right there, guys. I like that kind of question, and a lot of you got that right today. And I just want to kind of go back over it again so we can have time to look at it at home. Okay? So please watch this video, look over your notes again, and I look really, really forward to seeing your test scores tomorrow. You guys have a great evening.